we're going to flip all the way to one of the last problems on this thing. My pages are a little different than yours. So project question number 3, it says, I'll tell you in a second, but I just have to get there. On page 11, just like Vera said. So we're given a system of charges, right? And one of those forces that I gave you, the forces that I told you from Coulomb's law, it also had the same, that's an E, the same structure and setup as our gravitational force, right? Where we have a constant times charge of one thing times charge of another thing over r squared. But there was a big difference. What was the big difference between the electrical force and the gravitational force? Okay, you're getting at it. What is it? Now, we don't call it active, but what? Attractive, right? Because they're always drawn closer, but we know what with the electrical force? It can be attractive or repulsive, right? Not to anthropomorphize. Attractive, repulsive. Anyways. So what makes it attractive? What makes it repulsive? Huh? So what about the charge makes it attractive? Okay, opposite charges attract, right? What makes it repulsive? Same charges, yes. Wow, you sound a lot like Vera. Okay. So, in this problem, we're given the system of charges, okay, where we have a 6 microcoulomb charge, and we have a -3 separated by 2 meters. We'll make that one red. And we have down below one that's 4 coulombs, 4 microcoulombs. This separation distance here is 5 meters. And this separation distance here is 2 meters. Okay? Now, the first thing to do is you have to figure out the direction on the charge that you're interested in. So in this case, it says, it gives you a number of steps. Compute between the 4 and the 6, between the -3 and the 6, and find the total force on the 6, right? You see that? In part C, it says find the total force on the 6 microcoulomb. So let's look at the directions that these forces are so we know what direction the total force will be. So if you look between, forgetting this one for a moment, the red and the black one, what type of force is that? It's attractive. So it's going to pull this way, right? And it will pull that one like that, right? Does that make sense? Now what about between the black and the green? Repulsive. That means down like that and up like that. So the total force on the 6 is going to be what? You put them head to tail, and you add them together, so the total force is going to be off in that direction, like that. That would be the total force. That's T. So the signs are going to give you the direction of the forces. Okay. Now the first step says find the magnitude of the force between the 4 and the 6. Well, that's just Fe, K, Q1 Q2 over R squared. What was our K? Nine times 10 to the ninth newtons times meters squared over coulombs squared. Let me move this over. So I like to remember it by like 9E9, right? That's how you'd put it in your calculator. 9E9. 9E9. That helps remember it. So Q1, what's our one charge? Six times 10 to the negative 6 coulombs times, now you don't put in the plus minus because the plus minus helps us determine what? That it was going this way up, right? But we don't need it here for magnitude. We use the plus and the minus to tell us that this green one is headed up. So that can be a confusing point. So this is 4 times 10 to the minus 6 coulombs divided by the distance between them, 5 meters squared. So we bust out the calculators, which you should probably do this along with me to make sure that you know how to do it. We have 99 times 6e minus 6 times 4e minus 6 divided by 25. That gives us 0.00864. What are my units? Newtons. Force. You didn't get it? Okay, so you probably did something in your division. So if you don't use the E button, then you got to remember you have to use parentheses, right? So don't forget that. Did you get it? Okay. Everybody ready to go on to B? Numeral B. You guys are hard to entertain this morning. Huh? I barely slept last night. Claire thought there was a ghost in her room. So she traded spaces. I had to go up there, but I couldn't fall back. Then I realized it was because her window was open. So. And you're telling me you're tired. Okay, so B. B is the force between the 6 and the 3. I think I said we don't include the negative here. It just tells us that it's in this direction. Okay? Same formula. 9 times 10 to the 9 newtons times meters squared per coulomb squared times 3 times 10 to the minus 6 coulombs times 6 times 10 to the minus 6 coulombs divided by the distance between them squared, right? Now, we say the distance between them, we have it labeled as r because if you have these two particles, right, separated by this distance to here, right, and we spin that around, what does that make? They're always separated by that distance, which is a radius of the circle, okay? So 99 times 3e minus 6 times 6e minus 6 divided by 4. 0.045 0405 newtons. Now we have our red force and our green force here. And so the red is the what component? X. And the green is the... So if I want to get the total force now, as it says in part C, what do I have to do? That's right, p-tag it, right? For lack of, well, for whatever reason. So ft will be the square root of point, well, 0.00864 plus 0.0405, and we will get the value this will just give us the magnitude. Did you get 0.0414? Well, you rounded differently, but you got it, right? Close. Now that gives us the magnitude. What is the direction? How do we get direction? Michael? Well, you could use sine, but yeah, we are used to using the tangent, right? So this is part C, and then D would just be theta is a tan inverse of the y, which is green, over the x, which is the red. And that will give us the angle that we're at. Of course, we've done this with different types of various things, all the way back to displacement at the beginning of the year, remember? $12 degrees. Good. Now the next thing that we're going to do is break into some groups and do some whiteboard work. This will probably fill in tomorrow. So on one of these I marked it. Did I give someone a packet with writing on it? On the front page? No? Oh, here it is. Okay. So Paul and Aiden, you're going to grab a board and a pen and work on the first two questions on page 1. Okay? Marissa, you're going to work on group 2, greatest common factor. You know greatest common factors. I think I called it least common factor. I meant greatest common factor in the video. Or did he even get to that yet? Okay. And then Maya, well, how many do we have? Yeah. Maya and Leanne. I'm sorry, Kendra. Do you think I would know that? You guys will do 1 and 2 on page 2. Okay? And then, no, you work with, because we have groups of 2. Leanne and Spencer, you guys do 3 and 4. And then Carolyn and Vera, you guys can do number 5 on page 2. Okay? And Tyler, are you sick of working with him yet, or? Okay, just checking. Are you sick of her? Okay. You're going to do 6 and 7 on page 3. Michael and Caroline, sorry, you're going to do 8 and 9 on page 3. And then, what do you mean? Why don't you do 10 and 11? Kayla and Emma. Okay? That's all right. So I'm trying to learn how to get my, it's not that hard from what I hear, my iPad, which they just gave me, and I'm sure you have teachers that do it because Mr. Gerhardt's going to teach me, how to use the iPad where you can write on that and it goes right to the smartboard. So that would be nice. And then if I could just somehow hook up electrical currents to this, we'll just use these, and as you write. I'm going to stop this video now. I had 2 of these recording.